Hi, we're talking about slope fields today, which just happen to be the notes for 6-1. And to start out that, we're going to first of all talk about what a differential equation is. And I'm going to write the definition. So this is 6-1, again, slope fields. And it's the notes on these. And the first thing we're going to focus on is a differential equation. And what is a differential equation? Let me write it down here. Is an equation that has x, y, and dy dx involved in some manner in the equation. Alright, and so let's take a look. I'm going to look at a particular one, and this one is, well, you have different types of differential equations I should talk about. First of all, you have first order, and you have second order, and you can keep on going. You can have a third order if you wish. And that keeps going on forever. And the first order would be one that looks like this: y prime minus y plus 1 equals 0. And so I have y and excuse me, dy dx involved in that, and this would be a first order because I only have the first derivative. Second one would be something like this: y double prime minus y equals 0, and that would be a second order because I'm talking about the second derivative. And I'll throw in x on this one. So third derivative, you would have third derivative minus, let's say, xy plus y squared equals 0. Okay, so all those are differential equations: first order, second order, third order, and obviously as I take more and more derivatives, I can get fourth order. So I'm going to look at an example. An example I'm going to use is the differential is this one right here I'm going to use, and it's going to be y second derivative y double prime minus y equals 0. And so that's a derivative, and you have general solutions, and what you can do is general solutions would be equations such as y equals the sine of x, that if I plugged it into here would verify this differential equation. In other words, if I put the values of the second derivative of y and y into that, I should get 0. So I'm going to figure out what the first derivative is first, and that's going to be the cosine of x, because the derivative of sine is cosine. And the second derivative, the derivative of cosine, is a negative sine. And so what I'm going to do is I'm going to see if this specific solution, this one right here, works in this differential. So what I do is I substitute the second derivative version, which is negative sine of x, minus the sine of x, and see if it does indeed equal 0. Well, if I look at this, I get a negative 2 sine of x. That's not always equal to 0. So this is not a solution to this differential. Alright, let me try another one. Again, I'm looking at second derivative minus y equals 0. Well, now I'm going to try this particular one, and this particular one is going to be y equals e to the, excuse me, 4e to the negative x. So the first derivative is a negative 4e to the negative x, and the second derivative will be a positive 4e to the negative x. And now I'm going to substitute both of these in, and so I'm going to have 4e to the negative x minus, because that's what this is, 4e minus a negative x, why? Because that's what y is. And when I subtract them, I do get 0. So this is a solution to that differential because it was able to solve equals 0. Okay, in fact, I can go to a general form and say, all right, what if y equals c e to the x? Would I work then? Well, the first derivative of c e to the x is equal to c e to the x, and the second derivative is equal to c e to the x. And so now when I again plug each of these into this differential, I'll get c e to the x minus c e to the x is equal to 0. So I've verified that this also is a solution of this differential right here. Okay, let's take a look at finding a particular solution. And so the differential I'm going to use is y times y prime minus 3y equals 0. And I'm going to say, first I want to verify that cx to the third equals y is a solution. And then I want to find c if y equals 2 when x equals a negative 3. So I'm going to do that. So first of all, I'm going to take and figure out what the derivative of y is, and the derivative of y is equal to 3c x squared, and I'm going to plug that in. So I have x times 3c x squared minus, and now I'm going to plug that in. I'm going to have 3 times c x cubed. I can multiply these together and get 3cx cubed minus 3cx cubed, and lo and behold, I do get 0. So this right here is a solution to that differential. Now I'm going to find what c is, and I am told that y equals 2 when x is a negative 3. So I'm going to put a negative 3 in here. I'm going to cube it, and I get 2 equals a negative 27c. And so I get negative 2 over 27 is equal to c. So my particular solution, now that I've found c, particular solutions, you know the value of c. And it's going to be y equals a negative 2 over 27 x cubed.